Hey guys, today we're going to talk about the cosine rule, the proof of the cosine rule, and when and how to use the cosine rule. So by the time you get to this video, hopefully you would have a pretty good understanding of trigonometry, and you would definitely need to be familiar with using the sine rule and the area rule to solve problems involving non-right angle triangles before you get to this cosine rule, since the proof is going to be a little bit more complicated than usual. So firstly, we need to discuss why do we need the cosine rule. So let's discuss a case where I have a triangle and I have two of the sides. So let's say that's 12 centimeters and this is 20 centimeters, and this angle here is, let's say, 30 degrees. Now I know that you guys are already able to find the area of this triangle using the rule that we proved last lesson, but if the question was to find side length of x, you actually can't use the sine rule to do it, because let's say I have sine x over sine 30, then we don't have this angle here or this angle here, so it'll just be 12 over sine, and then let's call that angle B, 20 over sine angle C. You can't solve it, there's too many variables, so the sine rule is useless in this case if we want to find the side length of x. So what we want to do now is go back to basic algebra and use trigonometry ratios and see if we can somehow get to the variable x using the three values that we have, which are the two sides here and the angle there. So let's call the angles A, B, and C, and let's call the sides little a, little b, little c. And again, let's draw a perpendicular line down the middle and call it H. So the first thing we want to do is we want to understand that C is what we're trying to get to. This variable here is what we're trying to get to. So the first thing we're going to do is write an equation involving this variable, and then think about how we can use these three values that we have to get to that. So C squared is equal to H squared plus, and we need a quantity to describe this side length here, right? Using Pythagoras, once we have a value for this, then we can put it in this equation: a squared plus b squared equals c squared. So I'm going to label this side here, and you'll find out why soon. I'm going to label from the midpoint to angle C, I'm going to label this distance x. And if that distance is x, then to the left we then have a minus x. So therefore the Pythagoras theorem becomes c squared, let's go back to the beginning. C squared equals a squared plus b squared is the Pythagoras theorem. Now, using the Pythagoras theorem, a is this side here and b is this side here, and C is this side here. So we can use the Pythagoras theorem, substitute the values in. So we have h squared plus bracket a minus x squared. Okay, so we have written a definition for c squared, but you can see that this has nothing to do with the three values that we have. So we're going to, except we know that 20 is the same as a. So we're going to slowly find out how we can describe x and how we can describe h using these three values. Okay, so the next thing we're going to do is we're going to analyze the triangle on the right here. We're going to analyze this triangle here now using the cosine ratio. So the cosine ratio, cos theta, is adjacent over hypotenuse. And in this triangle here, if this is theta, then we have adjacent here and hypotenuse here. So therefore, I'm going to substitute the values into our equation. Cosine C is equal to x over b. And we can start to see a link. We can see x in this equation, and we can see x here. So let's rewrite this x as x equals b cos C. So I've moved the b to the other side, which makes it go from the bottom to the top. Okay, now what I want to do is I want to expand the bracket here because it's a bit hard to work with brackets. So I'm going to expand it. So I'm going to move the h. I'm going to expand the bracket. So c squared equals h squared. Now a minus x squared, if you remember how to expand, a minus x squared is actually a squared minus 2ax plus x squared. So if you're not sure how I just did that, you need to go back and watch the expanding tutorial. So this now is a squared minus 2ax plus x squared. So we have h squared plus x squared in this equation. And notice how in this triangle here, the right angle triangle on the right, we can also use Pythagoras theorem on this triangle. So c squared equals a squared plus b squared. And let's say this side is a, this side is b, this side is c. We can write it as b squared, which has nothing to do with this b here. This is referring to this b. B squared equals h squared plus x squared. So now what we can do is substitute h squared plus x squared, which also exists in this equation here, h squared plus x squared, as b squared. So I'm going to put this in place of these two variables. So I can now write it as c squared equals b squared. So I can get rid of these two things now. plus a squared minus 2ax. And what did we say x was? X is the same as b cosine c. So c squared equals b squared plus a squared minus 2ab cosine c. And now we have found the variable x. We can find that using these three values because let's say x is c, which is the one we want, and we have a and b here. Then this makes this side little a, this side little b, and this side is big C. So we have these three numbers here, b, a, and big C, in order to find x. So applying the cosine rule to this problem, I then have x squared equals 12 squared plus 20 squared minus 2 times 20 times 12 times cosine 30. Putting all that into the Google calculator. Making sure it's on degrees mode. 12 squared plus 20 squared minus 2 times 20 times 12 times cosine 30. And the answer is 128.3. And obviously we want to square root that. So x is equal to the square root of that, which is square root of the answer, which is 11.32. 11.33, rounded to 2 decimal places. So obviously, once you know the cosine rule, you don't have to prove it every time you want to use it. So if I just give you a triangle again, and I give you two of the sides, let's say that's 15 centimeters, 20 centimeters, 30 degrees, and I asked you to find x, then what you can do is actually I'll let you guys figure this out first. Come back when you're done. Okay, so what you can do is you can label the sides again using A, B, and C. So A, B, and C, and I'm going to label the sides little b, little a, little c, and then you can write out the cosine rule. So notice how whatever variable you have here, you're going to write that variable squared is equal to the sum of these two other variables squared, c squared plus a squared, minus 2 times the product of these two sides, a times c times cosine the angle inside. Let me just check if that's right. Yes, it is. So putting that into the equation, I have x squared equals 15 squared plus 20 squared minus 2 times 20 times 15 times cos 30. Putting that into the calculator, 15 squared plus 20 squared minus 2 times 20 times 15 times cos 30. Close the bracket, equals 105.4. Actually, you shouldn't round before you get to the final answer. So x is equal to the square root of that. So square root it. And we have 10.26. So 10.3 centimeters. Okay, thanks for watching the tutorial on the cosine rule. See you again next time.